Good morning. Today's video is about the atomic structure. The structure of an atom is known as atomic structure. Now, what is an atom? An atom is the smallest particle of an element, which is represented by the symbol of that element. For example, we write Cl, N, Cu. All these symbols are representing the name of the element, but they are not only representing the name, they actually are representing the one single atom of that element. These atoms are the basic unit of matter. So when I write Cl, it represents one atom. But if I write 2Cl, it means I am talking about two atoms of that element. Similarly, N is representing one atom, whereas if I write 3N, it means three atoms of nitrogen. The thing you need to remember is that this symbol not only tells us the name of the element, but is actually representing the number of atoms. Now, regarding the subatomic particles of the atom. What are the subatomic particles? The particles which are present inside the atom, we call them as subatomic particles. For example, this is the nucleus of an atom and the various shells that are present outside the nucleus, right? So this nucleus contains protons and neutrons, whereas in these shells are present the electrons. So in a nutshell, we can say that there are three types of subatomic particles. Number one, protons. Next one, neutrons. And the last one is electrons. As the symbol implies, protons are positively charged particles, neutrons have no charge, and electrons are negatively charged particles. The protons and neutrons are present inside the nucleus, and the electrons are present in the orbits or the energy shells. So basically we can say that inside the nucleus, the proton and neutrons which are present, we call them collectively as and whereas the electrons are themselves revolving around the nucleus. These nucleons which are present inside the nucleus represents the total mass of an atom. So here we have the total mass of atom that is present inside the nucleus. Now, why is that so? The atom which has got 3 subatomic particles, the mass of electron is negligible. They are so light, the electrons are so light that their mass is almost negligible. Whereas the mass of protons and the mass of neutrons, they are almost equal in mass. So whatever mass an atom represents is located inside the nucleus. So how can we define a nucleus? Nucleus is the core that is present in the center of an atom where the whole mass of an atom is located. That is, the central core of the atom is nucleus. So in a nutshell, we can say that the protons and neutrons represents the atomic mass. So now let us talk of atomic mass and atomic numbers with the help of this structure of an atom. The atomic number. Now, what is atomic number? The atomic number, first thing, is defined in terms of protons. Why the protons? Because protons are a constant number that is present inside the nucleus. In an atom, the number of protons is always a constant number. This number will not change. So in order to identify the element, the number of protons if are known, then we know that this atom having this particular number of protons belong to this particular number of name of element. For example, suppose I say that the number of protons are 12. What does that mean? That means that I am talking about an atom of an element which has got 12 protons in its nucleus. That means it has got 12 protons in the nucleus, right? There is only one element whose atoms have got 12 protons in the nucleus, and this element is magnesium. And hence we say that the atomic number of magnesium is 12, right? So here we have identified the element on the basis of the number of protons. And that is why I am saying that atomic number should always be defined in terms of protons. So how do we define atomic number? It is the number of protons. It is the number of protons present inside the nucleus of an atom. Correct? Now, we have read that in a neutral atom, an atom is always neutral. That is why we call it as atom and not ion. So in an atom, we know that number of protons are always equal to the number of electrons. Now the question again arises that why can't we write that number of electrons in the atom is called atomic number? Will it be wrong to say so if we define atomic number in terms of electrons? No, it will not be wrong, but since the electrons are not a constant number, they can be increased or decreased. जो number of electrons है, अगर आपका cation form हो रहा है, that means अगर आपका atom positively charge हो जाता है, that means आपका number of electrons कम हो गए. But if the atom becomes anion, that means by gaining the electrons, in that case the number of electrons will increase. So any quantity that is not constant. That means the number of which can always change. That cannot define atomic number. That is why the atomic number is defined not in terms of electrons but in terms of protons. However, yes, number of protons are equal to the number of electrons. Now let us talk of the second term, which is mass number. Now what is mass number? The mass number is the sum of number of protons and neutrons present in the nucleus of an atom, right? So it is the sum of number of protons and neutrons present in the nucleus of an atom. Now here the protons are 12 and the neutrons if are also 12, right? Then in that case, what will be the mass number of magnesium? That is going to be 12 plus 12, that is 12 plus 12 gives you 24. That means here the mass number of magnesium is going to be 24 magnesium. Okay, so it is the sum of number of protons and neutrons. Where are they? Inside the nucleus. Kiska nucleus? Of a particular atom, right? So do not forget to write this, of an atom. Is that clear? So we have learned two things, atomic number and mass number. Atomic number is number of protons in the nucleus of an atom, and mass number is the total sum of number of protons and neutrons inside the nucleus of an atom. 24 is also representing the number of nucleons, right? Now let us talk of how to represent these subatomic particles. The subatomic particles, that is the proton, electron and neutrons, are represented by obviously a charge and the mass. So the charge is written as the subscript. Any script which is written lower is called subscript. So here electron has got -1 charge and neutron has no charge. The neutron has no charge. What is the mass of proton? The rough or an approximate mass of one proton is 1. The approximate mass of electron is 0. It is almost negligible. It is so light in nature. And neutron, the approximate mass is 1. So that is how the subatomic particles are represented. Then how is the atomic number and atomic mass represented? The atomic number is represented by a capital Z and the atomic mass is represented by a capital A. Atomic number is Z and atomic mass number or atomic mass number is represented by A. Now with the help of atomic number and mass number or atomic mass, can we identify the number of protons or neutrons and electrons that are present in an atom? Let us see. Suppose I have got atomic number is suppose 12, right? I have got the atomic number 12 and the number of electrons are 12. how can I identify the number of protons here? Since the electrons are equal to the number of protons and protons is equal to the atomic number. So obviously the number of protons are going to be 12. So if atomic number is 12 and electron is 12 and proton is also 12, then we have the basic two subatomic particles. Now let us talk about, can we identify neutrons by only this given information? No. For that, what we need to have is one extra piece of information, that is how much is the mass number. Suppose I say the mass number is 12, right? So if the mass number is 12, now what is mass number? Mass number was protons plus neutrons, correct? So out of these two, I know that number of proton is 12. Can I identify the number of neutrons now? Yes. 24 minus 12 will give me my number of neutrons, that is 12, right? So that is how the number of neutrons are calculated. Now let us just change it a bit and let us have some different pieces of information. For example, I have got, let the mass number be 32, fine, and let me have the number of protons as 16. By this, can I calculate the number of electrons, neutrons and the atomic number? Yes. The number of protons are equal to the number of electrons, that we know. So obviously protons are 16, electron is also going to be 16. And we also know that atomic number is equal to the number of protons, right? So 16 is the number of protons, so your atomic number is also 16. Now what is the number of neutrons? We know that A minus Z gives us the number of neutrons. So 32 minus 16 gives us the number of neutrons, that is 16. So by these three calculations, we can calculate all the subatomic particles if we are told the mass number and the atomic number, or we know about the electron, proton and neutron numbers. Suppose now I have an element, suppose the element be X, एक element है X, right? Now if I want to write mass number and atomic number along with the symbol of the element, how am I going to write it? Whatever I write at the lower part, जो lower part है, whatever text that I write here, we call this as subscript, and whatever I write at the top, I call it as superscript. Okay, the lower one is subscript, the upper one is superscript. Fine. In this element X, how is the atomic number and the mass number written? So whatever is written at the lower portion, that is a subscript, is your atomic number, and whatever is written in the superscript is the mass number. So here how can I write this? X, Z and A. Fine. Now let us take a specific example. Let me take the example of oxygen. Right? Now X was any element. Here we are taking oxygen as the element. At the subscript, I am going to write its atomic number. So what is the atomic number of oxygen? That is 8. Right? And in the superscript, what am I going to write? The mass number. So that is going to be 16. So if you are given only the element along with the atomic number and the mass number, you can actually calculate its number of protons, electrons, atomic number, mass number, and even the neutrons. Here it will give you your neutrons. Fine. एक एग्जाम्पल देख लेते हैं. Let us calculate the different subatomic particles of oxygen using this information which is written over here. So by just having a look at this formula, we know that here the atomic mass or the mass number is 16. It is given. And mass number is 16 and atomic number is 8. Fine. So now what do? Protons, electrons and neutrons. To find them out, protons is equal to number of electrons and protons are also equal to number of atomic number. So proton and the atomic number is 8. Fine. And electron is also 8. What is the number of neutrons? That is A minus Z. So A minus Z, that is also 8. So that is how the atomic number and mass number generally tells us about the various types of subatomic particles that are present in an atom. Now with the help of the information that we have deduced by atomic number and mass number, let us try to find out how this helps us in writing the electronic configuration. What is electronic configuration? Electronic configuration is the distribution of electrons in their various shells. In the various shells. किसके various shells? Of an atom. जो हमारा एटम होता है उसके वेरियस शेल्स में ये इलेक्ट्रॉन्स कैसे डिस्ट्रीब्यूट होंगे, दिस वी कॉल एज इलेक्ट्रॉनिक configuration. Now, suppose you are given only this much piece of information and you are asked to draw the diagram of the atom. That is, draw the atomic structure of oxygen. This much is the only question you have got. How are you going to draw that structure? The first thing, find out the electronic configuration. Here, the electronic configuration is done of the superscript or the subscript. कौन सी script का configuration होगा? Super का या sub का? We are going to configure the electronic configuration of the number of electrons. The name is given over here, electronic. ठीक है, तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन में हमें नंबर ऑफ इलेक्ट्रॉन्स का कॉन्फ़िगरेशन करना है. नंबर ऑफ इलेक्ट्रॉन्स सबस्क्रिप्ट बताएगी या सुपरस्क्रिप्ट? Obviously the subscript will be giving us the number of electrons, that is here. Now we know in an atom there are certain number of shells which we name them as K, L, M, N. These are the basic 4 shells. Rest are out of the bound of class 9 syllabus. So here are the 4 basic shells K, L, M, N. So how are we going to draw the structure? Before that we should know configuration. So configuration requires 2 rules. What are those 2 rules? The first rule is the 2n square rule. Now what does this rule says? First thing, the n here represents the number of shell. Which number of shell are we talking about? So K is your first shell, L is the second, M is the third, and N is the fourth shell. If you draw a diagram of an atom, you will find out that if this is the nucleus, here is the K shell, then we have got L shell, then M shell, and in the end we have got N shell. This is K, L, M and N. Okay, and the K shell is considered as the first shell, L is your second shell, M is your third shell, and N is your fourth shell. So there are 4 shells that are present. Now how are we going to divide these electrons according to the 2n square rule? Now n represents the number of shell, and I want to find out how many number of electrons are accommodated in K shell. So how am I going to find out? 2. What is the first number of shell here? That is 1. 2 into 1 raised to power 2 gives you 2. So that means in the first shell I can have 2 electrons. How about the second shell? 2 into 2 raised to power 2 gives you 8 electrons. That is how the third one will be done. 8 electrons, and same for the fourth shell, 32 electrons. So the first rule that can help us in identifying that how many number of electrons can be accommodated in each shell is the 2n square rule. This is your first rule. After this comes your second rule that we call as, the second rule is the law of octate. Second is law of octate. Now what does this rule say? The law of octate. It says that the valence electrons of any atom must be in numbers, so that the atom can become stable and can acquire the stable electronic configuration of its nearest noble gas. देखो, octet का मतलब होता है 8. So हर एटम अपने स्टेबिलिटी को अचीव करने के लिए must have 8 electrons in its outermost shell. So that is given by the law of octate. Now let's have a question here. Up till this second shell, right? Here we have got 8 electrons, that is not an issue. Generally the students ask that if the 2n square rule says that the third shell can accommodate 18 electrons, then why? The law of octate is saying that an atom can only have 8 electrons and not more than that. Basically, देखो एक configuration करके देखते हैं. Let us have the configuration of sulfur. Here is the sulfur with 16 atoms as its atomic number. So configuration becomes 2, 8, 6. That is KLM. Here there is not a problem. 2n square well followed. Obviously जब आपके 16 ही electrons हैं तो 16 will be accommodated. Now in contrast, let us have a look at the configuration of calcium. Here the atomic number is 20. What will be the configuration? That is going to be 2, 8, 8 and 2. K, L, M, N. The basic confusion comes here in the M shell. In this one. यहाँ हमने क्या बोला कि K, L, M, N कि M shell में 18 electrons maximum can be accommodated. But what are we doing here? Here we are accommodating only 8 and 2 electrons have been written in the N shell. ऐसा क्यों? Here you need to understand that all these orbits M, N and so on, they all have a subshell. They all have a subshell, and if there are more electrons available, they will be adjusted in these subshells or suborbitals. This is beyond the scope of your syllabus. आपको बस एक चीज याद रखनी है, that is the law of octate. किसी भी शेल में आपको 8 से ज्यादा इलेक्ट्रॉन्स को accommodate नहीं करना है. Even though the 2n square is saying that yes, 18 electrons are accommodated, but we will be using only the 8 electrons here in this shell. So the configuration of calcium becomes 2882. This valence number of electrons is showing that the calcium is an unstable atom. Why? Because it has still not acquired the configuration of its nearest noble gas. That is why it is an unstable atom. Can we make this calcium atom stable? How can be done? By simply completing its octate. So in case of calcium, what will happen? The calcium is going to lose, its 2 electrons, and in the process this calcium will become Ca2 positive. That means the calcium atom now will become a calcium ion, right? And since the 2 electrons have been lost, the configuration of this calcium ion will be 288 K L M. The N shell will be finished since 2 electrons are lost. So here you can see, since the octate has been completed, the atom has become ion and has become stable. Right? Now let us have a look at sulfur. How is this sulfur going to complete its octate? Here, this sulfur is short of 2 electrons. 6 electrons are already here, so it is going to gain 2 electrons, and by gaining 2 electrons, this sulfur atom will become iron, right? And will acquire a -2 charge. And what will be the configuration here? It will become 288 KLM, right? This proves my point that why the atomic number is not defined in terms of electrons but in terms of protons. दोनों examples में आपने देखा कि number of protons even after gaining or losing of electrons they are still the same. यहाँ पर number of protons beginning में भी number of protons throughout the process was 16. जब 286 था तभी भी number of protons 16 था, और जब 2 electrons उसने gain कर लिए तभी भी आपका number of protons is still 16. Same is the case in calcium. Here, even after losing the 2 electrons, the number of protons The number of protons are 20 throughout the process. Fine. Now, what is a negatively charged ion known as? We call it as anion. And what is a positively charged ion known as? That is known as cation. Okay, so what is an anion? A negatively charged ion formed by the gain of electrons. And what is a cation? Cation is a positively charged ion formed by the loss of electrons. So class, I hope this is clear to all of you. In the next session, we will be discussing chemical bonding. Thank you.